All right, so now that we understand the principle of moments, it's time to actually use the principle of moments in order to solve our daily life problems. So here we have a seesaw in which we have, or you could just consider it as a balance, and we have a green box and a blue box, and we can already see the seesaw to be in a balanced state. So first, observation that we can make from here is that it is a case of balanced, uh, you know, a balanced state, and we can see that there's a green box and there's a blue box, and the weight of the green box is already provided, which is 10 newtons, and the weight of the blue box is not known, so we have to find the weight of the blue box in this scenario, and then we're also given the distances of the boxes from the pivot position, right? So the first thing that we can see is that it is balanced. That means the principle of moments is actually followed, because principle of moments was actually for the balanced cases, and you could if you can recall the principle of moments, it stated that for a body needs to be for a system needs to be in a balanced state. The sum of the counterclockwise moments should be equal to the sum of the clockwise moments, right? So this is a case of balanced system. So the total counterclockwise moment should be equal to the clockwise moment. So what is the clockwise moment here? So this is the clockwise moment, and this is the counterclockwise moment, right? So because these directions are this direction is clockwise and this direction is counterclockwise. We are provided the data of the counterclockwise moment, so let's actually calculate the total torque of counterclockwise moments direction, right? So the total torque in the counterclockwise direction would be the product of force times the distance. So the force in this case is 10 newtons. This is the weight, and the distance is of 5 meters. So 10 times 5 is 50 newtons meters. So the total counterclockwise torque is 50 newton meters. Now let's actually calculate the torque of clockwise moments. The torque in the clockwise moments is again going to be force times distance, but the force this time is not known. It is W times distance, which is 3, right? So it is going to be 3W, right? So 3W is going to be the total, the clockwise torque, right? And now that we know the system is balanced, the principle of moments says that the torque in the counterclockwise direction should be equal to the torque, or the sum of the torques in the clockwise direction. And now we have the value, so we can just equate them together, which would be 50 should be equal to 3W, and then W would be equal to 50 by 3 newtons, right? So it would be around 12.66 if you just convert that to a decimal value, but this would also do. So the weight of this box would needs to be 50 by 3 newtons in order to balance keep the seesaw in balanced state.